Here's another example where we can use integration by parts, and it's a bit weird. There's a bit of magic involved, but we get there in the end. What I'm going to do is I'm going to set this as my u part, the part I'm going to take the derivative of, and this is going to be v dash. Okay, so as you can see, I've taken the derivative of u and the integral of v, and I'm going to go ahead and all this integral here, I'm going to call that a. It's just a neat little thing that I'm going to say. So again, I write my little note to remind myself. So a, that integral, equals u times v minus the integral of u dash times v with respect to x. So it looks like, at first glance, it looks like we haven't really changed anything, but we're getting closer to a solution. We just have to apply integration by parts again. So I found u dash and v for this integral over here. I'm going to write the whole thing again. So my integral a that I'm trying to solve is sine of x times e to the power of x. From that, take away then take away the integral of So what I can do is I can take these negatives together. Negative times a negative makes a positive, and I'm going to write that all out again with the positive. And I'm going to expand in here. So this becomes positive cos of e to the x plus that integral, and then we're taking it away. You may notice this integral of sine of x times e to the x with respect to x is the original integral a that I was trying to solve. So now we have a equals there we are. Let's add a to both sides. Now I have two lots of a on the left-hand side. And I can take a factor of e to the x from the right-hand side. And then divide both sides by 2 to find the solution. And then always, always, always just add a constant at the end. Now what did a stand for? A stood for the answer. We solved and we found the answer to the integral was that amount there. So that's just a bit of tricky tricks. I'll see you later where we'll look at another trick.